it's more complicated than yesterday, but wire-wise and coding-wise, it's easier. Actually, coding-wise, it might be a little bit harder. But that's fine. Okay, so ultrasonic sensors. You want to read it for me?
Sensor, a device which detects or measures a physical property and records, indicates, or otherwise responds to. Ultrasonic sensor, an instrument that measures the distance to an object using ultrasonic sound waves. An ultrasonic sensor uses a transducer to send and receive ultrasonic pulses that relay back information about an object's proximity.
You should become a voice actor. That was really nice. Okay, so what animal uses ultrasonic waves to go through the night? Bats, exactly. So nature, technology imitating nature. Pretty cool, right? Anyways, so what are some examples of everyday objects we use ultrasonic sensors in everyday objects? Want to try one?
I know there's a piano instrument that relies on an ultrasonic sensor.
Sure. Okay. Another example is car washes. Car washes uses ultrasonic sensors. Another one is very high-end speakers. They use ultrasonic sensors to fill the room. So those are some examples of ultrasonic sensors. Okay. So let's just go behind the science behind the ultrasonic sensors. It's kind of important to know this to actually get an understanding of the code and the stuff we're learning today. So just understand that an ultrasonic sensor emits an ultrasound at 40,000 hertz, which travels through the air, and if there is an object or obstacle on its path, it will bounce back to the module. Considering the travel time and the speed of the sound, you can calculate the distance. So pretty much, as you can see down here, there is a VCC pin, a trig pin, an echo pin, and a ground pin, right? So the VCC is connected usually to 5 volts, so you just simply connect 5 volts to the VCC. The trig emits the waves, right? The echo receives the waves, and then the ground is just the ground, right? So how does this work, right? I don't have an ultrasonic sensor with me, but let's just say this is the ultrasonic sensor, right? The trig pin will emit waves at a certain object. Once that waves hits that object, it's going to reflect back, and the echo pin is going to receive those waves. So by calculating the time that it takes for the waves to go to the object and back, we're able to calculate the distance. And we'll go into the math in the next slide, okay? So, confusing stuff, but just understand some key parts. In order to generate the ultrasound, we need to set the trigger pin on a high state for 10 milliseconds, and that'll send out an 8-cycle sonic burst, which will travel at the speed sound, and it will be received in the echo pin. The echo pin will output the time in microseconds, the second wave travel. So, again, this is just graphs to show you. The trig pin emits a pulse, and then 840 kilohertz sound wave generated from the ultrasonic sensors, and then the echo pin receives that wave and calculates the time that it took. And a real life example is, let's just say that there's an object right here, 20 centimeters from the ultrasonic sensor, and a simple way we could calculate this is, first of all, ultrasonic sound waves go in the speed of sound. So by understanding that, we can say that v equals 0.034 meters per second. Again, a key rule in any physics, speed equals distance over time. So time equals speed over v, which is 20 centimeters divided by the speed, which equals the time it took. And then you can use the speed conversely. So at the end of the day, you guys want to remember this. Just understand that waves go in the speed of the sound, and we need to know both the time and speed to find the distance between the object. Okay, just understand that part, and you'll be good to go. Okay, so our goal for today, since we have 30 minutes less time, let's just go through this quick. Okay, our goal is to print the distance from an object to the serial monitor, and these are the items that you would need. Okay, so bring out an Arduino Uno, ultrasonic sensor, a breadboard, and wires. Okay, and then we'll continue. So you guys know the rule, just wire it up. Okay. So as you can see, very smart. What you should do is connect the 5 volts to the positive side of the breadboard and the ground to the negative side. Pretty much in every project that you do on your own, you just want to start out like this, okay? After that, thing is, right, we're emitting sound waves outwards, right? So make your ultrasonic sensor face outwards like this. Okay, at the edge. So not inwards, outwards. Okay? And you don't need to place it in the middle. Try to place it more at the edge, actually. That'd be better. So kind of like the LCD display, except the cylinders are facing outwards. Okay? The ultrasonic sensor, it says VCC, trig, echo, and ground. So just connect them accordingly, okay? Echo for this person, put it at port 10 and port 9 was trig. Honestly, because you're putting it near the edge anyways, just put it at port 2 or 3. I think that'll be better. And VCC connects to 5 volts and ground connects to ground, right? Okay. Ooh, what is ground?
It's the port we use for every product, and it's like a base.
Base, good. It's the reference, right? So again, if I'm jumping, how am I going to measure the height, right? I measure it off the floor to where I jump. So ground is the same thing. We need some reference point, 0 point, for us to measure anything, right? So yeah, just look at the pins and put it in accordingly. I think these are actually reversed, so just look at the pins in your actual component itself, okay? VCC connects to 5 volt, ground connects to ground, echo connects to let's say port 3, and trig connects to port 2, okay?
Are those business analog? Yeah, I think digital is usually like just turns on. I think digital is usually the one that like measures the integer values of like.
No.
That's definitely not.
So I think both measure integer values actually. It doesn't have to only be integer, but they do. So remember that we use digital if it's not continuous, and it's usually binary, right? Meaning that it's only 2 choices. And that's the reason why we're using digital, right? We're just inputting and outputting. There's nothing we have to really worry about other than that. But if it's something like a potentiometer, where variable resistance can vary from a range, then that's when we care about analog, right? Because it's in a curve for analog time. But okay, great. I'll give you guys 5 more minutes, okay? So try to finish until then. Boom. Okay, let me put this out.
Is this right?
Do you guys want to see?
This is not connected to this. 이거를 그냥 여기로 transform은 돼.
Okay, so let's go to the code. First things first, what do we do? First thing we do, oop, variables, great. Okay, what are our variables that we have to set up? So, what pins are we controlling? Actually, you weren't here, but what pins do you think we have to control in the sensor? You don't know? You want to give me a guess? How many? 2. Great. Okay, so let's do that. I'll introduce a new thing. You can define pins by just doing hashtag, or that's what you guys call it these days. Hashtag define. Echo pin 2. You don't need a semicolon if you put define, which is why a lot of people choose to do this. And trig pin 3. So remember, a trig pin is the one that exerts the sound waves, and the one that receives it is the echo pin. Okay. Okay. And let me introduce 2 variables. You'll probably put these variables as you code if you did this from scratch, but I'm showing you anyway. So let's put long duration and int distance. Okay. So what's happening here, right? Long duration. Who knows what? Okay. So someone explain to me what int is again. You want to give it a shot? What is int?
Int is an integer.
Integer, right? What is? Give me some examples of integers.
like numbers?
Sure. What numbers?
1, 2, 3, and so on.
Yeah, 1, 2, 3, -3, -2, just the whole number, right? Long allows you to put more digits, and it also allows decimals. So that's why we're using long, because our value can be very long. Okay, literally. So these are the only variables that we need for this program. Okay, so what do we need to do for setup? Give it a shot.
We need to define what is the output or input.
Okay, so what's the function we use to do that?
Pin mode, right?
Pin mode? Okay. What do we type next?
What's this one called again? It was like
So you don't need to care about that. Just look at your variables and then just do it.
echo pin.
Okay. Is echo pin input or output?
I don't think I was here good when I learned about the functions and all.
You didn't need to know the functions.
I'm not sure.
Just give me a guess.
Output.
Input. Close. So remember, trig pin is the one that exerts waves. Echo pin is the one that inputs waves. Okay, so if you know that, then give me the next one.
Then the trig pin would be output, right?
Good. Okay, so our goal for today is using the ultrasonic sensor, right? And reading the distances in the terminal, correct? Okay, so what do we have to write to start the terminal again? We did this yesterday. Do you guys remember what we had to do? I'll give you guys a hint. It starts with serial dot. Serial, yeah?
Serial. Again.
Begin, great. And then, what's next? Do you remember? 9600. So why are we putting 9600 here again? I'm just testing you guys a lot. Why do we put 9600 here again? Because that's the amount of bits, right, that we're going to send to this. Like that we're going to exchange. Okay, so what I'm doing here is setting up echo pin as input, trig pin as output, starting the terminal, right? And then let's just print out a title at the top of the terminal. And then just say ultrasonic sensor test. And on top of the terminal, the first line will be ultrasonic sensor test, okay? Great. Okay, so remember that I told you about pulses, right? That trig pin sends pulses at a certain manner, right? So these next few lines is just all about the pulse patterns that ultrasonic sensors send. Really, this is kind of hard to understand. Well, just try not to understand it, just understand the code part, okay? Okay, so we'll start with digital write. That's how we always start out. And we're going to use trig pin and sending it at low first. And we're going to delay the microseconds. So for 2. Okay, so by saying delay microseconds, it goes in terms of microseconds instead of milliseconds, okay? So this is smaller than milliseconds, if that makes sense. Okay, so that's the first send. The next send will be making trig pin high. So instead of low, it's going to be high now. And we're delaying microseconds, 10 microseconds this time. Okay. And then we're writing this as low. Okay. So this is pretty much the cycle, okay? The trig pin is exerting. Looks like I spelled stuff wrong right here, so let me just change that real quick. Okay, great. So, let me just send this outwards. Okay. What else do I have to write? Okay, so now that I exerted, right, trig pins, now I have to input stuff. So what's the thing that we input in? So let's use our variable of talk, duration. as a placeholder for our values, okay? And we're using pulse in, which is a ultrasonic sensor a function, and we'll receive it at high. And then we'll calculate the distance by equaling the duration by 0.034 and then dividing by 2. Okay, so trick question. What does this mean? What does this mean? You guys are trying not to stare at me so that I don't choose on you. Okay. I think you know, so yeah, why don't you give it a shot actually?
So we established that echo pin was input, and then we would get input, and then in duration, echo pin would be put on high, and then distance would be the duration times 0.
So, what's the key physics equation that I told you guys to remember, or that said that's useful to remember? Okay. Do you guys remember? Speed equals distance over time, right? Okay, so this is physics. This is some math, okay? So this is why math is useful, kids. Okay. Distance, so if speed equals distance over time, distance equals speed times time, right? If you just rearrange the variables. So we're getting duration with this function. So if you want distance, it's this the speed, right, which is 0.034, which is the speed of sound, right, times the distance, which is just the the time, right, and then this whole thing is going there and back, right? So we're dividing by 2 at the end because we only want one way of the distance. Okay.
Wait, why is it 0.034?
The speed of sound in meters per second. So, ultrasonic waves go in the speed of sound. Okay. So, do you guys get up to this part? I know it's kind of confusing, but okay, great. I'll just turn this on. Simply want to print the value that we earned right here in our terminal. Okay, so can someone tell me what to do? Someone want to give it a shot. How about right here? Give it a shot. What would I have to write to print out this value in the terminal?
Serial.println distance.
Great. Yeah. So let's just go like this. Distance. Or let's just first print this first, actually. So print. So let's just print this first. And then, so print line, the difference of print and print line is print line skips a line and then prints it. So that's the key difference, okay? You guys could mingle with it if you guys want. And then distance, and then let's just go like that. And remember, the distance is in centimeters, okay? Okay, so once you're finished with this, you should be done with your code. So run it and test if it works. And when you test it, you gotta put your hands on it and check the distance, right? And try to make your hand as flat as possible. Again, you have to open your terminal to see the values pop up. So we'll be using the ultrasonic sensor again. Because we're ending in 1 hour 30 minutes, let's just have a 7-minute break right now. A pretty fast break, and then we'll do more add on to this project after this. So this means your distance is not working necessarily. So try to figure it out, okay? Does yours work? No? Wow, great job. Good job, good job.
What's your resistors? Because it should be close together.
Great, great. So give it a shot. Can you explain the code to me? Do you know what I did here? So just start from the if statements.
Okay, so for the first if statement, if the distance is less than or equal to 30, like you set up your first LED to light up, and you also play a low sound.
So that 30 is that minimum criteria, that minimum distance you need in order for one light to pop up, correct?
Maximum distance.
Or Yeah, maximum. Sorry, maximum distance you need for it to pop up, right?
Yeah.
Okay. So yeah, keep going.
And then the closer you get to the sensor, the higher, the more LEDs that light up, and the higher the pitch of the sound.
Okay.
And the buzzing.
Can you explain this last part for me?
And as for it's printing in your serial.
So explain the if part first.
If the distance is above 30 or less than 0 or less than 0.
So why am I putting that criteria, that scenario in the first place?
Because if the maximum of distance is 30, so when you have something over 30 or 30, then in your serial monitor it will say it's out of range, and
No tone means what?
no tone,
Means no sound comes
no
out.
sound.
Okay.
And
So what's the else part?
then else part is if it is within range, it will print the distance. It will say distance and then colon and then your actual distance from the.
And then the buzzer would do what?
And then it would make sound.
What sound? Sound that is saved from the minimum distance we picked up, right? Okay, so then can you explain to me why do we even care about putting else statements in each of our if statements in the first place?
Because if there was no else statements, do we know what to do if it's not?
Incorrect. We'll still know what to do. Okay, here's why, right? Why do we even care about else statements in this scenario? When, as long as it works, it just has to light up, right? If it reaches that distance. Here's why, right? Oh, you want to give it a shot? Yeah.
So if it goes out at some point of that
Right,
it will reset.
Right. So this is what happens, right? I put it at 0, every light shines, and it goes to the maximum pitch, right? But what happens? So you remember, this is constant cycles. It constantly checks. So what happens if I put it lower? The lights are still going to stay on if I don't put an else statement. I need some way to reset the lights and some way to reset the sound. So that's why I put else statements throughout the code, okay? Okay, good that you guys know that. Okay. So, try to fix your issue, your close.
So that means you did not look at your You're not connected.
It's connected to the positive side, while the other side is connected to ground. Okay? So just double check that. Now, let's put this beautiful music down. What a great piece of art, honestly. Okay. You guys don't agree with me? Alright, so I'm just using the same code that we used last time. If you deleted it, that's just really unfortunate. So just copy as quickly as you can. Okay, so let's start. Again, remember that these numbers correlate with whatever you did. So change the numbers accordingly. I'm gonna just put random numbers in here, okay? Okay, so we're going to define let's just say your first LED, so like your closest LED, and I'm gonna just say whatever, like 13, and then I'm gonna define LED 2 as 12. You guys have 6, right? Yeah, okay. LED 3 as 11, define LED 4 as 10, define LED 5 as 9, and define LED 6 as 8, and then we're going to define the buzzer as well, right? That's the buzzer pin. And we'll go like 7, because we don't have 7. Okay, so adding on to the long duration and distance, we're going to add another variable called sound. And in here, we're going to say int sound is equals to 250. Okay. Okay. So can we guess what we have to do next? So, oh yeah, sorry, I should bring my code up. So, can we guess what we're going to do next? Someone give me a guess. How about you? Give me a guess. Are you still doing it? Okay. I'll give you a free pass. How about you?
I guess we're gonna run the same thing, like they're constantly checking.
So what are the steps in code, in our codes, for our Arduino again?
Define variables.
Right.
Set up with these.
Setup, right? So what's the only thing we set up so far?
Only the echo pin entry pin.
Yeah,
set up the
right.
LED.
Right. Okay, so then let's do that. And we also have to set up the house buzzing. Okay, so do you guys all copy up to this part, or do you guys want one more time? Okay. Yeah, I'll give you guys a little more time. So, all the LEDs are going to be inputs or output? Joey, give me the answer. Output. How about the buzzer? Try again. Output, great. Okay, so yeah, all the LEDs are going to be output, buzzer is going to be output because, you're exerting sound, not inputting it. Okay, so, great. We'll wait a little bit more, and then we'll start, okay? Okay, so let's start with the setup. Okay, so we can just skip a line right here. We'll go pin mode, LED is output, and then I'll use a very handy tool called copy and paste. Copy 6 times, 1, 2, 3, 4, 5, 6. So just name it 3, 4, 5, 6. Okay, and then we would also put buzzer. And then we're good to go for our setup. So a lot of stuff, but yeah, easy to understand. Okay, so I'll wait for you guys a bit. We got up to this part, right? By the way, I changed the print line to make it more neater. That's my fault. We should have print line at the end. But we basically essentially got up to this part, right? I added another digit to make it more accurate, by the way. So we went up to this part and we got distance. So now what we're trying to do is, depending on the distance, we're trying to light up a certain amount of LEDs, and also changing the pitch of the buzzer or vibrations. Okay, so let's start with that. Right here, we'll use something called Conditional Sentence. Again, I'm using a comment, so this is pseudocode. This literally has no meaning. I'm just doing this so that I can show you guys. Okay, so what do we start out as? The if statement. So let me just introduce how if statements work again, right? If statement is if a condition is satisfied, then you do whatever, right? Otherwise, you say else, and then you do that. So there's also else if, but we're not going to go that far today, so just care about if and else and understand this pretty well, okay? So if this condition happens, then do this. Otherwise, do something else, okay? So what's the first condition we have to care about? The scenario where the object is the closest, right? So let's see the condition, right? The condition has to be a Boolean, by the way, meaning it has to be true or false. So let's make the condition distance is less than or equals to 30 centimeters. So if it's less than or equals to 30 centimeters, right? So you guys can make it closer if you want, honestly, but I'm gonna just do this because you guys can test it out as you go. Let's go LED 6 high, actually 5 high, and then sound 250. Otherwise, digital, quiet, LED low. Okay, so can someone explain what I'm doing here? What am I doing here? You want to give it a shot?
You're making the LED 5 brighter, and
Mhm.
then make a sound.
Sure.
And then, if the distance is less than or equal to 30, and if it's not, then turn the first LED off.
Correct. Oh yeah, sorry. This should be LED 5 by the way. But yeah, you got the point, right? Essentially what I'm saying here is that if it's less than 30, right? We turn, so at this point we turn this guy on, right? And then your sound gets set. And then if it's not, then we just don't turn it on. So the reason why we're putting sound right here, if that's your question, is because we're going to later set the buzzer to that certain sound.
I was just wondering where we define sound.
Okay, yeah. Oh, we define sound up top. As equals to 250. Okay, so then here we go, okay? Basically, I'll quickly finish this code and then explain it to you, okay? Wait, actually, let's just go LED. I think it's LED actually. Sorry about that. Let's go LED for now, okay? So then we'll just copy this. So we want to go into this in increments, right? So the closer you go, the more you show lights. So let's go in increments, okay? This is what we'll do, okay? So copy and paste. So I just copy and pasted this whole segment. If it's less than 25 this time, so not equals, just less than 25, or you guys could do equals also, it doesn't really matter. The sensor's not that accurate anyways. We'll go LED 2, and we'll make the pitch higher. So what am I doing here? If this is at 30, right? I'm lighting the first one, and I'm setting the pitch at a certain time, right? So that's the first scenario. However, if the object is closer, the first one is lit up and the second one is lit up and our pitch gets set higher. Does that make sense? So depending on this, we change the, we just add on to it. And what happens if that scenario doesn't get satisfied? It just doesn't get satisfied. Okay. So then we'll paste this again. So just try to track this with me. So it's less than 25, now we'll do less than 20. We'll go LED 3, and then this time we'll go 290 probably. Or let's go 280 because I'm not sure how high we'll go. Wait, let's see. Let's go 250, 260, 270. Yeah, that'll be better. Okay. So we'll do the same thing over again. So remember, we're doing this a total of 6 times, right? So if you want to go ahead, just copy it 6 times. And we'll go LED 4 next. And this time we'll go 280. And then we'll go less than 15. Okay. And then we'll go, let's see. We'll copy and paste this again. We'll go less than 10 this time. And then we'll go LED 5. And then we'll go 290. So we're just incrementing, right? And we're reducing the distance by 5 each time. Okay? And we do this a total of 6 times. So one more time for us. And then we'll go for this guy 5. LED 6, LED 6, and then we'll go 300. Okay. So, and then basically we satisfied every scenario from distance equals 30 centimeters to 0, right? That's what we did. So we have to figure out what happens if the distance is less than or equals to 0 or greater than 30. Okay? So that's the last scenario that we have to care about. So if distance is greater than 30, and this 2 symbols means or, by the way, and distance is less than or equals to 0, right? We'll say serial print line out of range, and at the same time we would have no tone, okay? And then we would do else serial print distance serial. So we just copy this actually. So just copy this up top. That, and then we'll do. This is where we put our tone. Okay. And then we would delay at the end. And then we delay 500 at the end. Okay. Okay, so that's it. Let me explain this code after this. I have to take a call really quick, so just wait a second. Set it up so that it looks nice, because code has to look nice, guys. Believe it or not. I gave you a lot of code, so let's see if anyone can really explain this to me. I wonder. I'll be surprised if you can, actually. Okay. So, let me just go out a little bit. Or, okay, you guys are still copying? Okay. Let me just go out a little bit for you guys, like that. Okay, so can someone explain the code to me? Or are you guys still typing? Still typing? Okay. We'll wait a bit then. So this means your distance is not working necessarily. So try to figure it out, okay? Does yours work? Oh. Wow, good job. Good job, good job.
It's your resistors. Because it should be close together.
Great, great. So give it a shot. Can you explain the code to me? Do you know what I did here? So just start from the if statements.
Okay, so for the first if statement, if the distance is less than or equal to 30, like you set up your first LED to light up, and then also play a low sound.
So that 30 is that minimum criteria, that minimum distance you need in order for one light to pop up, correct?
Maximum distance.
Or maximum distance you need for it to pop up, right?
Yeah.
Okay. So yeah, keep going.
And then the closer you get to the sensor, the higher, the more LEDs that light up, and the higher the pitch of the sound.
Okay.
And the buzzing.
Can you explain this last part for me?
And as for it's printing in your serial.
So explain the if part first.
If the distance is above 30 or less than 0 or less than 0.
So why am I putting that criteria, that scenario in the first place?
Because if the maximum distance is 30, so when you have something over 30 or 30, then in your serial monitor it will say it's out of range, and
No tone means what?
no tone
Means no sound comes
no
out.
sound.
Okay.
And then
So what's the else part?
else part is if it is within range, it will print the distance. It will say distance and then colon and then your actual distance from the.
And then the buzzer would do what?
And then it would make sound.
What sound? Sound that is saved from the minimum distance we picked up, right? Okay, so then can you explain to me why do we even care about putting else statements in each of our if statements in the first place?
Because if there was no else statements, I do know what to do if it's not.
Incorrect. We still know what to do. Okay, here's why, right? Why do we even care about else statements in this scenario? when as long as it works, it just has to light up, right? If it reaches that distance. Here's why, right? Oh, you want to give it a shot? Yeah.
So if it goes out at some point of that
Right,
point,
right.
it will reset.
Right. So this is what happens, right? I put it at 0. Every light shines and it goes to the maximum pitch, right? But what happens? So you remember this is constant cycles. It constantly checks. So what happens if I put it lower? The lights are still going to stay on if I don't put an else statement. I need some way to reset the lights and some way to reset the sound. So that's why I put else statements throughout the code, okay? Okay, good that you guys know that. Okay. So try to fix your issue, your close.
So that means you did not look at your school.
It works.
You're not connected.
Can you follow your